Hello everyone, we from Group 2A are here to share with all of you about the characterization of homogeneous catalyst. We have chosen our catalyst based on this paper right here. It's a palladium complex supported on silica. Now, here are the members of Group 2A. We have non-cyanophytrin, we have Ain, we have Sharvin, we have Aryani, and we also have Fatin. Now, without further ado, let's look at our catalyst.
We choose Journal of Silica Supported Palladium Complex, an efficient, highly selective and reversible inorganic hybrid catalyst for the synthesis of E-stilbene. The selected catalyst for the homogeneous organometallic catalyst related to elemental analysis in this journal is palladium 2-diphenyl diketone monothiosemicarbazole PDDKTS APSG for synthesis of stilbene in microwave reaction system. Advantages of using palladium is over the past few decades, wide range of palladium-based homogeneous catalysts have been used in this coupling reaction due to their high selectivity. For silica, as supported to the palladium 2-diphenyl diketone monothiosemicarbazole PDDKTS APSG in this reaction are very promising because its high surface area, good thermal stability, ready availability and economic viability, relatively easy covalent modification with organic and organometallic moieties. Function of catalyst palladium 2-diphenyl diketone monothiosemicarbazole PDDKTS APSG is high selectivity and reusable organic for synthesis E-stilbenes in condition high turnover frequency and mild reaction condition. The benefit of palladium 2-diphenyl diketone monothiosemicarbazole PDDKTS APSG is economic viability, easy preparation, high catalytic activity, good stabilities and reusabilities, no measures palladium leaching, and viable alternative in cross-coupling reaction on efficiency, environmental concerns, and economical grounds.
Elemental analysis is an experiment that determines the amounts of an element in a compound. In this analysis, they have several characterization techniques such as atomic absorption spectroscopy (AAS) and X-ray fluorescence (XRF). Atomic absorption spectroscopy is based upon the detection of wavelengths of light absorbed by an element. Meanwhile, X-ray fluorescence is a non-destructive technique for the determination of elemental composition. Each characterization technique has its own basic principle. The basic principle of atomic absorption spectroscopy (AAS) are firstly, a sample is introduced into the atom cell where it is dissolved and then exotized. Next, the analyte atoms forms, then quantitatively absorb light in a proportional manner to the concentration analyte atom in the cell. After that, the light, which is at a specific wavelength, is then isolated from other wavelengths that may be emitted by the atom cell and then detected. Next, the basic principle of X-ray fluorescence (XRF) are a primary X-ray typically generated in an X-ray tube, hits an inner shell electron of the atom and ejects the electron from the atom. Then, the open position is filled by an electron from a further outer shell and fluorescent radiation is emitted. After that, in an energy dispensive XRF instrument, the fluorescent radiation is collected by a semiconductor detector. And last, the signal is collected in a multi-channel analyzer, and this process handles each X-ray one by one but at high speed.
This is the important list of the characterization for palladium diphenidiketone monothiosemicarbazole. Firstly, elemental analysis are consist of energy dispersive X-ray spectroscope and atomic absorption spectrometer. From the elemental analysis, we can get the percentage rate of nitrogen, carbon, and hydrogen. Lavendia AA7000 atomic absorption spectrometer was used to determine the content of palladium in palladium diphenidiketone monothiosemicarbazole. Next, energy dispersive X-ray spectroscope was used to determine the qualitative of metal in catalyst. The peak on energy dispersive X-ray spectroscope spectrum are clearly confirmed the presence of palladium in catalyst.
Now, the data obtained from the characterization techniques used on the catalyst. So first we did elemental analysis using atomic absorption spectroscopy, AAS, and what was obtained was that the content of palladium was found to be 0.7% weight by weight percentage. And then next what was done was elemental analysis using energy dispersive X-ray, fluorescence spectroscopy, EDXRF, and what was obtained as shown in the graph was, yes, palladium was found to be present inside the sample. As shown in the graph, where the spike is at the point where palladium would be.
Next, it is about the importance of the information then obtained from the assigned characterization techniques. By using an atomic absorption spectrometer, it will identify the amount of metal in liquid. So, to determine of metal loading, the catalyst was digested in 10 ml of nitric acid in a microwave digester system for 10 minutes and diluted sufficiently by double distilled water. The resulting solution was subjected to AAS for metal analysis. The palladium content of the catalyst was found to be 0.7 weight percentage of silica. Next, energy dispersive X-ray spectroscopy is a chemical microanalysis technique used in conjunction with scanning electron microscopy, which is SEM. SEM image at low magnification reveal that silica gel bits do not possess any cracks during the preparation of catalyst, confirming its good mechanical strength. Next, in terms of high magnification, SEM micrograph depicted the uniform dispersion of palladium complex on the surface of silica, which is responsible for its high activity.
All in all, PDDKTSAPSG catalyst or palladium 2-diphenyldietone monothiosemicarbazole catalyst is used in the synthesis of steel beams using the Suzuki cross-coupling reaction. The catalyst was characterized using elemental analysis. It was analyzed using AAS and also EDXRF, and yes, palladium was found to be present at an acceptable level using the elemental analysis. That is all from us. Thank you.